Hello, and welcome to this next session for CKA exam mock exams. So in this session, what we're basically going to look at is number 2. So the mock exam number 2 by Code Cloud. So if we kind of go to our a Code Cloud interface here, you can basically see that I've already started the actual mock exam number 2 here into the CKA practice exams here. So as part of this Code Cloud, you do get quite a good interface. You get a timer, you get a weighting. It does kind of give you a bit more kind of realistic approach to how your actual exam would look. So it's just a little bit more kind of practice on how you would actually perform during the exam. But for today, what we're basically going to do is we're going to go back over to the YouTube series here. We're going to go to series number 2, and we're going to go to this folder called Kubernetes CKA exam. So really what we're going to do is we're going to go down to mock exams number 2 here. So this is series 2.7 for this video. So if I come down here, I've obviously put some information about how you would actually register for Code Cloud. But if I come down to the actual questions here, so the question number 1 basically says take a backup of the ECT cluster and save it to that. So just what I'm going to basically do here is I'm just going to run the actual exam answer that would be required here. So I'm just going to run that. But while that's basically running, what I'd like to also do is make sure that you have ChatGPT open as well, because ChatGPT will also kind of give you the necessary answer of what you're looking for here. Now you won't have access to this during the exam, but while you actually practice these questions, it does kind of help to kind of reinforce the theory that's been sort of said, but also make sure that you actually have the Kubernetes documentation beside you so that you can actually find that information about backing up an ECD cluster, and practice understanding where exactly that answer actually is. But for today, in the interest of time, what I'm basically going to do is I'm just going to actually list out my opt here. So my folder that I basically saved it to, so you can sort of see that the snapshot was saved at opt, and it's called ECT backup.db, and I can sort of see in my opt folder here, I do actually have my backup here. So that basically satisfies question number 1 here. So we're going to move on to question number 2, and it says create a pod called that with that image with an empty directory that lasts for the lifetime of a pod. So as we know, when we create an actual empty directory type volume, it does actually only last the lifetime of a pod. So if I was to put something into this empty directory of the pod and deleted the pod, it would actually get removed completely. So it's just a way to kind of practice that you actually also kind of understand what an actual empty directory is. So if I kind of sort of say, let's create our pod here, and let's just vi into our pod here. Let's just remove the lines here for one moment, and let's sort of say, we're going to take the actual necessary code here. I'm going to put that inside here. So I'm going to copy that in here, and you can basically sort of see that everything really was the same of the original pod, but all I'm basically doing is specifying that the volume here for cache volume should be an empty dir. So if I kind of save that back here, and I create and describe my new pod here, you can sort of see that in the volume section here, in the cache volume, you can see that there's a type of empty directory, and it does actually tell you that a empty directory that shares a pod's lifetime. So that basically satisfies this question here. So let's kind of move on to number 3 here. So it says create a new pod called super user pod with image busybox, allow the pod to be able to set system time. So this is a kind of interesting one where you could basically use ChatGPT again. So if I kind of went to new chat here, and let's sort of say I sort of said Kubernetes system time capabilities. So system is one option. So it's a Linux capability that allows a process to set a system time. When a container runs on Kubernetes node is subject to the same Linux security features and restrictions as any other process. So again, we're kind of, apart from kind of coming over to our kind of information here, and searching for security context on our actual pod and Linux capabilities here, what I'm basically trying to do is just trying to highlight that there's kind of different ways to actually, get some information about, as you're kind of learning and studying. But at the end of the day, you really are kind of coming over to this documentation here to ensure that you do actually understand the the question of what's basically being asked in this document here. Um, so let me sort of say, like, here's exactly where you would actually be setting it here. So this is really the kind of the question here. This is really the answer here that we also kind of need. But I also kind of have it. But what I'm going to do is I'm going to just update that just so that people can actually read that. Because again, as I find little things, in the actual in the notes. I mean, these are my real notes here that I'm basically working through with the exam as well. So I am making kind of updates to that. So the first thing we want to do to answer this question is clear the screen here for a second, and let's kind of create our superpod. So super user pod has just got the YAML file. Let's just kind of modify the YAML file before we actually create it, and let's sort of say the notes sort of say add the following under resources field. So you have to make sure that you copy in exactly what you're required here. So I can sort of say set paste here, and I can come down here, and it says under resources field. Now, honestly, there's going to be no resources in this. There's going to be no resources here, so you probably could actually remove that resources line. But I'm going to leave it just for time's sake here, because again, every time that you can kind of save time in the exam, it certainly does kind of help you. So let's sort of see. The next thing it sort of says is because it's a busy box image, you also need to add this line under the name. So let's kind of do that as well. So this should go under the name. And let's put this one here. So now we can sort of say, because this is the kind of the last time we're going to review this, create a new pod called that. So the name is that. With an image busy box is that. Allow the pod to be able to set the system time. We've done that. That's those 3 lines there. The container should sleep for that time. So that's those lines there. So we do look like we basically have met the criteria of the question so far. So if I go down here and I create the pod here, and let's just make an alias here. K is equal to kubectl. I put that into the notes as well if you're unsure, but let's sort of say k get pods. And you can actually sort of see that the super user pod is actually running and created. Now, the question itself doesn't, it doesn't ask you to re-verify that it's actually working. In the documentation here, it does actually show you how to actually verify that it's actually working. Again, it depends on your time, to be honest. If you really have the time to verify it, it's definitely something that you should do. If it's a simple thing, maybe you could use that time for something else. So it's going to be up to you to how your exam is basically progressing, whether you would actually have time to verify every single item within the exam. But let's kind of go to question 4 now. So it says the pod definition file is created at that. Make sure to use the manifest file and mount the persistent volume called that. Ensure the pod is running and the PV, which is the persistent volume, is bound. So the mount point is that, persistent volume name is that. Okay, so this one has a little bit more to it. So the first thing we'd actually have to do is kind of clear the screen here. Is we're going to create a user PV. So we're going to basically have a user PV file here. So I'm going to sort of say, let's sort of see what we actually have here first of all. So we were provided this, by the way. So this use PV we were basically provided. So right now we have one persistent volume, which is PV-1, and then we have no claims. So we've no persistent volume claims right now at the moment. So the first thing I'm going to do is I'm going to create a claim here. and I'm going to come into here. I'm going to create the persistent volume claim here, and basically just make sure that it matches up to what's actually been specified within the exam question. And we're going to create that system volume claim here, and you can sort of see that it actually has these characteristics of the persistent volume. So it sort of says the PVC should be in a bound state now. So is it in a bound state? It is in a bound state. And then it says, here's more details about claims as volumes and then how to use. So you can kind of go back into this. Let's just clear the screen here for a second. You can kind of go back into this file that we sort of said here. Remove. It says remove everything after the tag name. So really, what I'm going to just do in the time here is I'm just going to DG, which is basically remove all lines, and I'm basically just going to recopy in the lines. So obviously you'd be going over to a PVC and PV in your Kubernetes nodes, but right now basically what it's sort of saying is, here's a pod. Use the pod is actually called use PV. You basically got an Nginx image, you've got a name, you've got a mount point, which says the mount point should be data, the system volume should be dat, and that is all what looks like what we need. So if we kind of come down to here, let's sort of see if we can, this creates here. So the pod is created, and let's kind of describe our pod here. And we can sort of see that the volumes is myPD and the type is persistent volume claim. And it looks like it has data. There's the data. So it looks like it actually has everything. So this pod actually looks like it actually has everything that's required. So let's sort of see. And kind of, when I kind of ran it there, I sort of saw that, the actual, the state was in waiting. So it just kind of took a minute or two to basically kind of go into an actual running state. But basically there's a pod that's using the private virtual persistent claim. So that looks as persistent claim. Yep. So that looks like we're good. And that had a little bit more weight because obviously it would be a little bit more detailed. So let's kind of go into our next question here. And again, try to be kind of finding the information here over in your Kubernetes and trying to be asking ChatGPT what the actual response there is. But question 5 basically sort of says, create a new deployment called Nginx deploy with image dat and one replica, next upgraded to rolling. So this is something we sort of saw before, so this is quite kind of easy as well, in the sense where all you actually have to do here for this kind of question, let me clear my screen here, is kind of first of all create your deployment with that version of Nginx, make sure that that's successfully created. Then what you want to do is actually scale your deployment. Now this is a kind of a strange thing that I kind of found that, certainly when I was kind of studying for another exam on Kubernetes, but, even though it sort of says you're actually only kind of scaling it to 1, I would still run the actual scale command just to make sure that, you have it in the history that it's actually been scaled in the events of the actual deployment. So it definitely just kind of helps it, even if you saw the pod was 1, just make sure you kind of run the actual, what it sort of says here. So the next thing we actually want to do is actually upgrade the deployment to version dat using a rolling update. So you can also scale your Nginx deployment. Sorry, I need to just get that updated command. So if I kind of go back down here, and I'm just going to take my set image here. So what I'm going to do here is I'm basically going to set the image. So I'm going to set the image of deployment using Nginx, and I'm going to make it now 1.7, and I'm going to record it because probably right now, if I kind of kubectl describe deployment, Nginx deploy, you would see that it is actually 1.6. So I'm going to do that, and basically can sort of see that the actual images has been updated here. Now, again, in the interest of time, I cannot run every single command that's really kind of required, um, because the video would just be far too long. But you do kind of get the point here that there's a bit of kind of repetition going on now when we sort of saw between the lightning exam plus the kind of first mock exam. So um, it definitely helps. But this also had a kind of weight of 15, and that would have been quite an easy question to actually find, and complete, because if you kind of went to the Kubernetes on how to kind of scale deployments, you would basically find that kind of quite easy. So let's kind of move on to the kind of question 6 then. So in question 6, this is something that's a little bit more kind of tricky. So this has definitely got like a weight of 15, so it's quite a good weight here. But let's kind of, clear the screen here. So it says, create a user called John, grant him access to the cluster. John should be able to do that in the development namespace. The private key exists at this location. So you've got a private key, you've got a certified request here, and you've basically got an important note that says, as it's Kubernetes 1.9, the certificate signing request object expects a signer name. Okay, so they've kind of given you an important note here, and then it says, please refer to the documentation to see the example. So, you're looking to sort of you're kind of looking to kind of break this up a little bit, right? So how you'd actually kind of tackle this is, first of all, create a user called John. Second of all, kind of create grant him the access to those verbs inside the development namespace, and then you're basically looking to actually assign and approve the request for that user. So every single user, when they make a request into the cluster, they have to be approved, and that's when the certificate signing request has to be approved by administrator. So really, the way you would probably do this is it says here. So let's kind of try this. First of all, we're going to go here. Then we're going to, because we want to sort of see that certificate signing request here. So we do actually see a certificate request here. Tail, I'm not going to do this. I don't think it's that important right now. But I'm going to look here, and I can sort of see that I need to get this certificate sign request in base64 encoding. So that's all that's all that's basically doing. It's looking at the actual previous request and getting it in the base64 encoding. So now it's kind of where we would basically want to create a file here, and we'd want to put in the certificate signing request, and just make sure again, it said in the actual exam question here, or the mock exam question here, really that the signer name is important here. So as of Kubernetes 1.19, the sign request requires a signing name. So make sure that you kind of do have actually that actually listed as well. But really, all you're actually doing is you're putting the request in the base64 into the official certificate sign request for John, who's going to be the developer. So that's essentially all you're basically doing, and then you're basically creating this certificate sign request here, and you sort see that like John, the developer, he's been created, and then we can sort of say we can basically obviously these are mock exams, right? So what the kind of point is, you can imagine that a kind of an administrator kind of came in, and he sort of sees that basically, or she sees that there's a new pending request here for somebody called John Developer. Now he would probably check internally if John Developer is a new hire or somebody like that, but they'd probably check and just make sure that that person is actually valid. They should be granted access. Probably the better way to actually do this is also obviously, have some ticket that's assigned and being approved by his own manager and hierarchy. So, but let's sort of say the exercise is just really for, how to create these type of sign requests. So you can sort of see that he's actually been approved. Now, the next thing is really kind of, we have to create a new developer role, because imagine that, we didn't have actually any developer role previously. So let's kind of create a developer role here. We can kind of describe, so we can get the role. So we've created it in the development namespace. We can get the role, we can describe the role, and then we can kind of get the cluster roles. Now, really kind of the next big kind of part for us is really, assigning the user John into that namespace and as that developer role. So that's where you're creating a role binding between John, the developer, and that role. So if I kind of go in here and I create that, so it says, okay, so that's created. I can now describe the rolling. Now, here's some kind of nice things to sort of say. Here's some nice checks to sort of say, okay, can John actually update pods here? Can he do this? Does he actually have access to this? Yes, he can. So can he actually delete pods? Um, yes, he can. Because basically what happened was, when we created this developer role, in the verbs, we basically gave him the ability to create, to list, to update. So probably, it depends on real life scenario, but the kind of point is that, this practice is just really to sort of see um, that everything is kind of created successfully, and then it's not meant to be, replicating a production system, um, in the sense where for permissions outside of that scope. But it does looks like we created the user, we granted them permissions, that namespace, we used that key, we used the sign-in name, then is he approved, his role and access, and he has the appropriate permission. So it does actually look like we've actually kind of created everything that's required for this question. Then kind of going on to number 7, it says create an Nginx pod called Nginx Resolver using Nginx. Expose it internally with a service. Test to see if you're able to look up the service and pod names in the cluster. Use the image for DNS lookup, and save or record the results in that file and that pod. Okay, so really what we're looking to do is we're just basically creating a new pod, and we're going to create the DNS lookup, so to have the actually, got the service DNS resolution correctly enabled. So what I'm going to do here is, obviously kind of go down to this DNS to this DNS service here. But really, first thing I want to actually do is I actually just want to put a little space between those, because it looks a little bit yeah, that's a bit nicer. So basically, the first thing I'm actually going to do here is I'm actually going to clear that screen again, and I'm going to create this pod here. So I can sort of say get pods. So I can sort of say k get pods here, and I can sort of see that my Nginx resolver is running, and it's 9 seconds old. So next thing I want to do is actually I want to expose the pod. Now here, here it doesn't actually specify a port, but I believe that you would actually have to have it expose a port 80, expose the pod and the name service on port 80. So I do believe that you actually have to specify a kind of default port, even though the question itself doesn't say port 80, but I think that's kind of implied that you basically do that. And then you would, describe the pod, and then you basically create a new busybox image with a sleep of 4000, so that this is like a little kind of trick here. So you're creating a busybox pod, but you don't want it to delete. So this is like a kind of little trick here to kind of keep it alive. So if you sort of say get pods again, you can sort of see here's your busy box, and it's basically running. This is your busy box pods, and it is basically still running. But here, what I want to do now is I want to actually execute into that pod, to that basic box pod, and I want to basically do an NS lookup on the Nginx resolver service. So you can sort of see that there's a service, there's an address, there's a service, and there's an address. And what they're looking for really is that information over into the file, the necessary file here. So let's sort of see here. The first thing here we're really doing is we're creating the busybox pod, doing the NS lookup into resolver, and then save the results into the service file, which kind of is what we sort of see right now. And really what we should do here is also do a kind of cat here to make sure that we can actually sort of see that that file has been written to directly. Okay, so this is when we kind of cat the file, we can sort of see, here's the actual output of the file. And again, the exam is testing your kind of speed. It's not testing on, some of the actual items. It's not testing on kind of how pretty, unless it sort of specifies like, it requires something like custom columns or something to format the view correctly. But really, this is kind of good enough for the exam. So don't spend time, making sure that this is really, really pretty. Just making sure that you could complete this question rather than make it actually pretty. So the kind of second part is, where you're taking your busy box, you're doing your NS lookup on that default pod, and then you're kind of outputting that to your Nginx pod. So let's sort of say Nginx pod. Save results to pod file. IP address uses dash. IP address uses dash here. So I have a kind of little note here that I'm going to just make really kind of clear here. So this is where we kind of save the results to the pod file. But it says the IP address here, IP uses the dash, not dots here. So I'm just going to make that kind of clear, because that's not very, very kind of clear. So here I can sort of see that my resolver service was actually this in this case. So what I'm going to do is I'm going to exit. I'm going to Control C out of that for a second. So I'm going to come out of that for one moment. And what I'm going to do is I'm going to kind of just go back to my resolver service here. I'm going to come back here. And you can sort of see that, the actual resolver service itself actually has this IP here. So I think I need to update. So this looks like if I was to update this pod here. So the first thing I need to do is make sure I get this IP here. So it looks like it was 150. But I think I need to replace these. So default pod cluster local, default service cluster local. So let's see if we can just use that. So let's see what kind of happens when I kind of do this. First of all, yeah, okay. So it is resolving basically at that IP there. So on every single time the actual IP for the resolver service is actually going to update and change. So that's why I needed to kind of just update the notes kind of quickly to sort of say this is the new actual IP here. So what I'm going to do here is just sort of say here your IP could be, well, will probably be different. Okay, so it's just a kind of note here that says that your IP is probably going to be kind of different than mine would be. So this mode, then it's should use the IP with that. Okay, so let's kind of that appears to kind of that we now have. If we cat this file and we cat the kind of the other file here, so I'm going to also kind of put that in here. So say cat and that. So if we kind of just run our kind of two cats again, we basically have one service file which outlines the service, which is this, and then one Nginx pod file, as the name suggests, for the pod itself. So you can sort of see it says test that you were able to look up the service. So that's the kind of first file, that service, and pod names from within the cluster using that image. So that appears to kind of have satisfied that result. I don't think the question is honestly, that kind of clear. Maybe that's kind of something for Call Cloud, but I don't think it's really that clear of what you'd actually have to do there. But I believe I've actually satisfied that. But let's go on for a second. And again, even if this kind of happened in the actual exam, itself, I think the exam maybe might, kind of clearer, but really, that's why you kind of have, saving time, because you can actually go back and kind of review something, if you weren't kind of overly kind of confident the first time. So you do get kind of time to kind of go back. So the first thing I want to do here is to say create a static pod on node 1 called critical, Nginx critical with that. And this actually looks to be the same question. This actually looks to be the same question that we actually had previously. And I kind of liked the way I kind of did the notes on that one. But just for kind of today, we'll kind of go on with the kind of notes here. So the first thing that you actually have to do really again is kind of look up in the kubelet config file the actual static pod location. And don't forget, like, your kubelet may not have that. I've sort of seen that before, that the kubelet may not actually have that value specified, and if it didn't have it, you'd actually have to add it. But right now, this kubelet on this control plane also does actually have it. So let's sort of say, so create a static pod. So the first thing I want to do here is I want to SSH into my node 1 here. So I'm going to SSH into node 1. And I'm going to, I just want to run that cat again just to sort of see. So that this time it does not have it on node 1. That's okay. So let's kind of go on. So basically now what we have to actually do is we have to actually add that location to the node 1, because right now you sort of saw before that the control plane actually had the kubelet, remember, runs on every single node, and the control plane node actually had that manifests file, that manifests location specified, but this node does not actually have it. So what we actually have to do is we actually have to add that location here. So what I'm going to do here is I'm going to go in here. I'm going to VAR. Let's sort of say, let's come down here. Let's sort of see, where do we need to add it. So basically, static pad needs to go under the shutdown grace period critical pods. So shutdown grace critical pods, which is here, and just press enter and paste in a file like this. Come back out by pressing escape, WQ, exclamation mark, to save that. That looks good. And let's just kind of restart our services and check our status of our services again. Because remember, we're still in as root. And you can sort of see that the kubelet service is actually now up and running. So that kind of looks good. And now, if we kind of check now to sort of see, do we actually have anything inside of our manifests. So right now, all static pods basically get into the manifests folder. So that's basically where you're supposed to be creating your static pods. So right now, let's kind of go back to our question for 1 second. Let's re-verify before we move on. So it says create a static pod on node 1, so we're in node 1, call that with an image that. Use the ECT Kubernetes manifest as the static pod path, for example. So that definitely looks like we're okay at the moment. So one thing I want to kind of do here is, because if we pwd, we print to actually in as root. So I'm going to create a new critical nginx critical YAML file into the etc Kubernetes manifests file. I'm going to enter on that. I'm going to copy our pod. Actually, that's just going to look a bit strange because the exit that. Let's just sort of say, let's just not save that for a moment. Let's kind of go back and kind of save our file. Because I noticed that if you kind of copy directly from GitHub, you kind of get a little bit of a strange pasting kind of going on. So I'm just save the file. I've kind of come back out, and I'm just going to go back in again, and I'm going to VI into a pod again. I'm going to save that, and that now it looks kind of, like two spaces, and then your third space is always your YAML. So that looks an awful lot better. Save that file, and now let's sort of see if we can sort of see any pod. Well, actually, first of all, we need to come out of root and exit out of that. So now I'm actually back in as root, and I can see that what's happened here is the nginx critical node 1 is up 17 seconds. Now, as we kind of know with static pods, the question says that it create a static pod on node 1 called that. Now, if I sort of say get pods -o wide, right, you can actually sort of see that the actual node that we're really, interested here in is actually it is actually the node 1 that it was actually created on. So the actual node here, the name of the actual pod here is nginx critical, and it's on node 01. Now, with static pods, they do get the name appended to them. So that's why you sort of see the -01 node here. But basically what it says is create a pod on the node 01 called nginx critical, and put it into that. So what we did was we, you know, we started off with our control plane. We just kind of verified, so to see where the actual control plane actually had their static pods. Then we went into the node 01 and we checked and sort of see, well, we didn't actually have any static pod location. And in that case here, but we added it here. We restarted a kubelet, we enabled a kubelet, and we checked the status of the kubelet, and the kubelet basically service was back up and running. And then all we did was actually kind of go into our manifest and sort of see if we actually had any files running there. And we actually didn't, because nothing came back here. And then we kind of created this new file here for nginx critical. We updated this to be an actual pod. And once you basically leave that running, because the kubelet is actually looking at this, it's looking at that location that we'd actually added for the manifest file here. So when you'd actually restarted it, any file that basically gets dropped in that looks like a pod, it will basically actually create the pod. So that does look like we've kind of satisfied that question too. So what I'm going to do now is I'm going to clear that. And you can sort of see, if you just do kind of, get pods or get a wide, as we sort of did before, you could also sort of see, that the actual pod is actually running, and it's up on node 1 there. So that does look like we've kind of satisfied everything on that exam so far. So let's kind of end exam. let's sort of see how we did. And again, even, the point of these mock exams, and the reason that, people do kind of pay for the type of mock exams is to practice these type of items. So definitely here, like it sort of says here, question 7 here, pod DNS resolution recorded correctly. That's something that I need to kind of go back into and actually reconfirm, because I think we did kind of create the pod correctly, and we created the DNS service correctly, but I definitely need to go and check about that DNS resolution for the pod itself to make sure that I'd actually done that correctly. So I'm going to just quickly check that now. Okay, so kind of looking back here, I kind of realized what my actual mistake is. So really, if we let's just kind of save these notes so that we don't put others wrong. But basically what happened was that I took the DNS IP inside of the actual the DNS file when I should have actually taken the IP from the pod. So I didn't actually follow this here. So it says get the IP of the resolver pod for the next command to work. So that's really what I should have actually done. So I should have actually just kind of went in and did a kind of a dash o wide on my pods. So kind of like this, and if I kind of look down at my actual resolver pod here, so this is my kind of resolver pod here. If I look down here, that was the actual IP here, and I used basically the wrong IP from kind of inside of the actual. I used it looks like a kind of cluster IP or something, but basically that was the IP that I should have actually used when I was testing this. So basically, what you need to kind of do to kind of verify that the actual pod has the DNS resolution is first of all get the IP of the pod for the resolver, for the Nginx resolver, and then from that, what you're basically doing is you're then basically using that IP inside of here with the default cluster local, which kind of provides you this. So basically, from inside my busybox pod, I can NS lookup to the pod IP, and then using the actual rest of the DNS resolution here. So whether you kind of use the service name or whether you use the pod name, that they both should basically work. And then you basically sort of save that out to a file. So you can sort of see now that we're at 100%. And I've updated the notes there just to make sure that that's kind of really kind of clear for the next time. I would actually run through it. But that's the end of mock exam number 2, and I will see you in the next one. Thank you.